a diffraction grating has 250,000 lines per meter. What is the wavelength of incident light if the second order bright fringe occurs at 12.6 degrees? Well, we're being invited to consider the diffraction grating equation. D times sine of the angle is equal to n times the wavelength. N is an integer, and to have a bright fringe you need the path difference d sine theta to be equal to a whole number of wavelengths. So for bright fringes, n is equal to 1, 2, 3, and so on. So the second order bright fringe is telling us that n is equal to 2. And with that, all we need to recognize is that the spacing between fringes, d, is equal to 1 over the number of lines per meter. So it's 1 over 250,000 per meter. So in terms of units, 1 over per meter is meters. So this will give us an answer in meters, which is our preferred unit of length, which is equal to 4.00 times 10 to the minus 6 meters, which is also equal to 4 microns, if you like working in microns. So this is now straight substitution. If I take the original equation and divide both sides by n, then d sine theta over n is 4 times 10 to the minus 6 meters times the sine of the angle, which is 12.6 degrees, divided by n, which is 2. That will give me a wavelength, 4.36 times 10 to the minus 7 meters, which, if you like working in nanometers, is 436 nanometers. So that is the wavelength. And we should check our answer by substituting back into the original equation and making sure that d sine theta times twice that wavelength are equal to one another. Make it nice for the marker, tell him where your final answer is, and we're done.